So welcome to this video on SI units and dimensions. We're going to find out about units and dimensions. We're going to explain why it's worth thinking about them. We're going to decide where to annotate our units and then prepare our rocket engine.cs class for takeoff. So the 7 base units. Let's just take a look at Wikipedia to start with for these base units. If you come over to Wikipedia and go to, or just go wiki SI base unit, you'll find this page here. And you'll find that there were just 7 units that absolutely every physical quantity can be represented in terms of. Some things are unitless, angles are unitless, percentages are unitless, a lot of coefficients, factors and things are unitless. But otherwise you can break everything down into one of these 7s. Now there are dimensions and there are units. Because there's a one-to-one correspondence between dimension like length, mass, time, current, etc., with meter, kilogram, second, ampere, we're just going to be talking about the units, specifically the SI units, the System International units, to make sure that we are just clear and precise about what we're talking about. So what we're talking about here is to get you in the habit of using units. Why? Why do we care? Why do we want to annotate our units in our code? Because it gives us a check on everything we do. We're about to start coming up with equations, coming up with ideas for equations ourselves, looking up equations, and we want to be able to make sure we can check our logic. So if I said to you 1 meter equals 4 feet, well, that could be correct as far as dimensional analysis, unit analysis is concerned. It isn't correct, as it happens. 1 meter is less than 4 feet. But dimensional analysis just tells you that it could be right. It also tells you that 1 meter equals 4 kilograms cannot be right, because the dimensions on each side are fundamentally different. We have meters on one side against kilograms on the other. So we want to write these down. We want to start becoming immediately aware of it. So where are we going to do that in our code? So let's just get some more kind of standards for ourselves. Firstly, looking at the top of Physics Engine, I'm giving mass a basic value here because I want to give it some common sense value that that makes sense, but it gets overridden in the inspector anyway, so I don't find it particularly useful to give it a value here. So I'm going to get rid of that, and then I've got to decide between several different ways of annotating this code. Let me just talk you through a few of them. Here's a slide that will show you some of your options. We could do a // comment. Wouldn't show up in the inspector. It would have excellent code readability, and it wouldn't show up in the pop-up. That is what we would be doing if we, for instance, come along here and say kg, which is actually what I'm going to suggest we do. Let me just show you a couple of other options. // would give you a summary. It wouldn't come up in the inspector. It would make our code less readable, but it would pop up in the IDE. Let me show you in case it excites you. So say we did this for the velocity vector. 3 / automatically puts that code in, and then I could say the velocity vector in, and I could just put the units here. I could go meters, seconds to the -1, for instance. Okay, let's just see the effect of that. If I come down into a method and start typing velocity vector, look, I get a summary in the pop-up. So that's pretty handy for me, but I don't think it's worth the cost of all that extra code. You can strip out both of the summary lines if you want, so you could end up about as simple as that, and it will still work. Okay, so pretty handy if you're deep down in your code and you want to know like the units and you want to know what you're dealing with, but I still don't think it's worth the cost. Okay, let's take another look back at the slide and see what another option might be. Using the tooltip annotation. Well, this would give you a pop-up in the inspector. Again, it would wreck our code readability, and it doesn't help in the IDE. Let's just look at that quickly. We could, for instance, come here and say tooltip, not tooltip, and then we put some brackets, and we go, I don't know, we could just put the units, ms to the -1, like that. I'm going to put units in square brackets always, and we could close off our tooltip. So this syntax here, let's see the effect on the pop-up, if anything. Nothing. So we've lost the IDE functionality, but if we go over to Unity now and click on ball, and you hover over mass, or velocity vector rather, is the one we did, you see the units coming up there, and you can put any arbitrary size tooltip you want. So useful tip, but again, I don't think it's worth the wait. What would your final option be, or the last one I can think of, is doing a suffix on your variable names. That's disgusting. It won't show up in the inspector. It won't work in terms of code readability. In fact, you can't even use that caret. That's why I've made it red, the little caret -1, and it won't pop up in the IDE. So overall, I hope you agree that commenting is probably as simple as anything. If you are the developer and you are deep in your code and you want to know what the units of mass are, you come to the top and you just look and see. If you are a designer and you want to know in the inspector, well, you could provide them a tooltip. Alternatively, they maybe could just go into the code and just look at the top. So that is how I'm going to suggest we do it. So that's fine for kilograms. Let me find you something a little bit more tricky, and then I'm going to challenge you to just finish off the annotation yourself. So let's go into add force. Pop into add force. Okay, and let's add in a couple more different things here and change this add force into a rocket engine class. So you can click on add force and use the refactor. Rocket engine, it does lots of things for you. It changes the name of the class, references to it, but also the file name, which is very handy. Now let's think about what we need in a rocket engine. Well, we're going to need to know a few different things. Firstly, we're going to need to know the fuel mass that this rocket has, and it's going to be a float. Ooh. That's fine, so fuel mass, and then that would have a certain number of dimensions, which I'll ask you to fill in. Pretty simple. What else would we have? Well, we'd have a public float max thrust. That might be a good one. And that's going to be in what? Well, let me fill this one in for you. This is going to be in, I'm going to determine it in kilonewtons because it's much more convenient and it's where you'll find it normally stated. So if you say kilonewtons like that, and then in brackets, ask yourself, what are the units of kilonewtons? Well, given that F equals ma, force is mass times acceleration, the units must equal the same units as mass times acceleration. So they're kg for kilogram, that's the mass bit. Acceleration is meters, seconds, to the -2. So breaking down the units of force, newtons has a units of kilograms, meters, seconds to the -2. Now, if you're not sure, again, go to good old Wikipedia. Go to Wiki Newton. You may need to disambiguate a little bit. Newton unit. And it will show you here, kilogram, meters, seconds to the -2. They're using a / notation. I prefer the to the minus notation. So back at our code, there's a couple more things we're going to want for our rocket. We're going to want to know what the current thrust percent is, like so. And this force vector is a bit confusing. It's not really a force vector, it's a thrust vector. But also, this is for us to tell the rocket engine which direction to thrust in. Because we're talking about a max thrust and then a percentage of that max thrust, they're actually talking about a unit vector. So let's rename this thrust unit vector. That's very clear. All right, so now your challenge is to go through and neatly annotate the units of everything in both rocketengine.cs and physicsengine.cs as I've just shown you. So go ahead, pause the video, annotate all your units as comments now. Okay, welcome back. Let's whip through them quickly. Let's start with physics engine. So kilograms, fine for mass, and we're going to use kilograms. So the base unit is kilograms, the actual unit is kilograms. Velocity vector, that is going to be in meters, seconds to the -1. Net force vector on the physics engine. Well, we'd better go decide between kilonewtons and newtons in here. I think because it's a general physics engine, not necessarily just about rockets, we're going to go with newtons. So what are the units of newtons? So I put newtons outside, and then I'm going to say, well, force equals mass times acceleration, so it is kg for the mass bit. The acceleration is meters, seconds to the -2. There you go. There are your units in the square brackets. Your base units are in the square brackets, and your actual kind of commonplace unit is there. All right, so that's fantastic for that one. Everything makes sense. The physics engine has mass, velocity, and net force. Let's come out of that. Rocket engine, fuel mass. Well, what's that going to be in? Let's just put it in straight kilos for the moment. We might want to make it a bigger multiple, but there's not really a kind of bigger multiple of kilos. So kilos is good. Max thrust is in kilonewtons, the base units of which are newtons, or mass times acceleration. Thrust percent, what units are that? Well, it has no units. It's dimensionless, so I'll leave it empty, or maybe safer to put none in there, so it doesn't look like you've forgotten to type anything. The thrust unit vector. What are the dimensions of that? Well, again, it's just a unit vector. It's pointing in a direction. It is actually unitless. we're going to have to multiply this thrust unit vector by a thrust to get something in newtons. If it was anything but unitless, then doing a multiplication of a thrust unit vector, i.e. the thrust direction, by an amount of thrust would give you something that's not newtons, which wouldn't make sense. Okay, so this is already starting to see the benefits of this dimensional checking lark. So, well done. We've done a lot here. We have got a lot more aware of where we are. We have a great architecture. We've done a lot of groundwork. Thank you for sticking with me. Some people would dive straight into doing the exciting rocket engines and things, but let's celebrate the fact that we have a really strong foundation now. And in the next video, we're going to flesh out this rocket engine class and actually have a rocket engine that consumes fuel and that throws mass out the back and that exerts an appropriate amount of thrust. And that's all going to be damn cool. So see you soon.